In exercise 2, we're going to create some tests for the utils class. Now, the utils class has a method for concatenating words together. So we're going to provide it a string of words, and then it's going to put that string together. It's going to put those pieces together into one sentence. Compute factorial is designed to compute a factorial of a number, of a positive number. And then finally, we have a normalize word method here as well. So let's take a look at our, if we want to write a test for this, of course, we have to create, just like we did before, we have to create the test class. So I'm going to go here, I'm going to go down to Tools, I'm going to create the test. I'm going to change the name of the tests to utils JUnit 3 test. Framework is going to be JUnit. Select test finalizer and test initializer if not selected. Click OK. The setup and teardown methods that we see in here are designed to allow us to do any work or to perform any actions that we need to do before we start testing. So the setup and teardown allow us to create objects, set values, or call or run any other code that needs executed before we can actually begin testing. While it's not really needed here, I do want to show it to you just so you know where it is should you ever want to use it. So we're going to go ahead and add in print line statements to both the setup and teardown methods. So I'm just going to type these in real quick. And then I'm just going to do a quick little print line statement for again, it's just a class name colon method name. Just again to let me know that those methods have executed. That's really all we're doing. Now, if I needed to create a utils class object, I would, but all the methods we're going to be calling out of these classes, notice, are defined as static, so objects are not required. So we'll head back into the utils test. All right. Now we need to write a test for the concatenate word method. Again, what you see on my screen is the default, is what they write as sort of a default test. It's sort of to get you started. It does not stand in the way of. It's just to get you started. Okay, I'm going to go ahead and change this. I'm going to go ahead and delete this method because I don't want it. I'm going to create my own. And we're going to call this public void All testing methods are public and void. Test hello world. They don't take any arguments. I am going to write a quick little print line statement, again, just to identify in the testing output what method this is. And you can create your own methods if you want. And I'm going to do one simple little, I'm going to do an assert equals. I want my result to be hello, comma, space, world, exclamation point. And I am going to call my utils class, utils dot concatenate words. I'm going to provide it with the word hello with a comma and a space. That's going to be a word. World. And then an exclamation point. So what it's going to do, that concatenation, is going to take these pieces and put them together, and the result should look something like that. And that's what we're testing. So if we run this, whoops, I keep forgetting that when you're running tests, you have to right-click and go to Run File. So one of my tests passed, one of my tests failed. It did the setup, compute factorial, and the teardown, which we haven't done compute factorial yet. And it did the setup, the teardown, the normalized word, which we haven't done yet either. But at the very top, it did the setup. It did the method hello world there as well. And you can see we didn't call the teardown. All right. So that is, again, using assert equals, writing my own test method, and using assert equals to do it. The next thing that we're going to do is we're going to do compute factorial, except we're going to get rid of that. And what I want to do is show you how to write a test to find out if a method is taking too long. So if we look at the next part of the exercise, we are going to create a method. Again, public, void. We're going to call it test with timeout. And we are going to check and see what happens how to find out when a method runs too long. So we're going to create this, and you're going to see that we're throwing two exceptions. Now, again, I've realized that we have not discussed exceptions yet. This will all be made clear to you later. Just know, for now, that when you are checking for deciding how long something's going to run and then have it fail if it runs too long, you're going to have to throw an exception. And to do that, you have to let Java know what exceptions you're going to be throwing. We're going to throw the interrupted exception and the timeout exception. Either one of those may happen. Oops, and it looks like I misspelled them. I think we're also going to need to add an import, which is java.util.concurrent.timeout. All right, now that we've got that timeout in, or we've included that library that we need for the timeout exception, we can continue with our code. So we're going to do our system.out.print line so that we know, again, what method this is we're running. Utils JUnit3 test, and this is the test with timeout method. And in order for this to work, we're actually going to have to do some threading. First of all, we are going to get a value. We're going to set up a variable, a constant actually. We don't want it to be able to change while our program is running, so we're going to do a constant called factorial of, so that we have a number, a decently sized number to get a factorial of. So I'm going to do int 3000 times math.random. So I'm going to use the math.random to get me a random number. I'm going to multiply it by 3000, convert it to an integer, and add 1 to it, just so I know that I'm dealing with a whole number that's at least 3000 or higher. That's going to make sure that we get a large number that has to be processed. I'm going to print out a statement that says that we are working on this. That says computing. Whatever the value we're actually getting a factorial of. And the mathematical symbol for factorial, which is a exclamation point. Now, in order for this to work, I have to have a thread running. And I have to allow it to run for a while. And basically what I'm going to be checking for is whether or not I actually have to interrupt that process. So I'm going to create a thread object called test thread. Now, the actual ins and outs of threading are a little bit beyond this class. I'm just showing you this because it makes an interesting test. Inside that thread, it's actually sort of its own object. We're going to create a public void run system.out.print line factorial of equals. Essentially what we're doing is we're letting our factorial utility run and produce some output. And if it produces its output in the time that we allow, great. If it doesn't, then we're going to have some problems. And I forgot a set of curly brackets, or a set of parentheses. I gotta make sure everybody has their... Oh, no, we were good there. There we go. Now, as far as this structure goes here, the thread structure, for now, that's just the way it's got to be. Threading is a topic that they'll get into in 244. It's not a topic that we really discuss in 130. Like I said, we're only using it here because we need this to run in the background on a separate process, which is what a thread is. A thread is a separate process. We need this to run in the background because in the foreground, which is our program, we're going to be essentially monitoring it. We're going to start this thread up. And then we're going to wait. We're going to wait for 1,000 milliseconds. And then we're going to interrupt the thread. We're going to call the interrupt method, not thread, test thread, interrupt. Now, what the interrupt method does is, unless the thread has completed, this will essentially stop it. So unless that background process we've started has completed, this will stop it. And now we just ask the question, if test thread dot is interrupted, that means did it finish or did we stop it? And it will return true if we stopped it. If we stopped it, then I'm going to throw a new exception, a timeout exception. With the message, the test took too long to complete. And I'm going to go ahead and run this. Oops. Here again, got to remember, have to run the test file. Both of our tests passed. That means that it managed to compute the factorial in under 1,000 milliseconds. Let's see if it can do it in under 500 milliseconds. Let's run it again. Still passed. Still managed to compute in less than 5. Let's see if it does it in 10 milliseconds. It finally failed. It took too long. Test with timeout failed. Caused an error. The test took too long to complete. So that just means that it takes more than 10 milliseconds to complete this process. If that's too long of a wait, then we got to go in and rewrite our method and make it more efficient. But if it's not too long to wait, then we don't need to worry about it. We can up that number a little bit. This is a way to make sure that your methods are executing, especially methods that might take a long time, that are executing under whatever your threshold is. Sometimes when we are assigned a project, we get a response requirement. That means that our application has to return a response in so many minutes or so many seconds. And this is a way to write a test around that responsiveness. You can create test methods, as many test methods as you want to run. Now, there are times where we might want to test for an expected problem. We may want a problem to occur. We may know that a problem is going to occur, that we are going to get a particular exception. And basically what we're doing in the next one is we're calling the compute factorial method again, and this time we're providing it with a negative number that we know should fail. We absolutely know it should fail. If it does fail, we can check for that failure. If we go back into the utils class, and again, I apologize because we haven't really discussed exceptions, but when we have methods that might let us know if there are problems, they are required to tell us what kind of problem they may give back. We can then handle that problem. If that problem occurs, we handle it, the test passes. If that problem doesn't occur, then there is a method called fail that we can run that says, hey, this method, this is done. This test is done. Something happened, and we have to force this test to fail now. So if we look at that, let's create a method. Let's create this method. Again, all test methods are public, void, and have no arguments. Test, expected, exception. So here again, we always like to print out what test method is being run. So we always print out the class, just for our own benefit, and the method name, test, expected, exception, method. Helps when I put semicolons in. And then I'm going to, we use something called a try-catch block to handle these exceptions, and I'll go into this in more detail when we get to the exception handling discussion in class. And the try part is where we put the code that might cause us a problem. So I'm going to go ahead and create a constant integer. And we're going to use the value -5. And then we're going to print out a statement just sort of displaying the results nicely. And if that completes successfully, I want this to fail because we did not want this to pass. There was supposed to be an error here. And we were expecting an illegal argument exception, but we didn't get it. Oops. There we go. All right, let's run this test. And we've got 2 out of 3 tests passing. Oh, hold on. Let's change this back so that passes too. We should have 75%. 3 of it are 4 tests passed. Again, normalized word failed because we haven't fully written that one out yet. But because we can't do a factorial of a negative number, our method is saying, okay, if that happens, we're just gonna pass on an error. We're saying here, okay, if that error occurs, let's handle that, and then the test completes just fine. Now, if I put in a positive number by accident, if I test with the wrong data, let's say, this test should fail, and it does. And it fails, and it says, illegal argument expected. We expected there to be a problem, and there wasn't one. Now, let's say we want to disable a test so that it doesn't run. We want to keep the code in here. We don't want to remove it, but we just want to make sure that that particular test doesn't run. Now, I had you write a test in the example, but I can actually just go here and type in all caps, disabled underscore in front of the name of the test. And when you go to run the test, it won't run. Whoops. Let me change this back to a -5. It won't run. Assuming that all the other tests are good, everything should pass. There's only 3 tests now. There are actually 4 test methods written, but because we put this disabled here, it's not running. Now, if you want to run your test, you can set the main project. We can do run test project, and that will run all of our tests. This one will actually run all of our test classes for us. And you can see there were 5 tests total. This is one of the reasons why we do this text. So utils.junit test expectation expected, test with timeout, and then test hello world, and then you see our vectors test for test equals and test scalar multiplication. You can run each individual test file as you write it, or you can write all your tests and run them at once using the run option up in the menu bar. All right, that's it for exercise 1. And exercise 2. If you have any questions about either of these exercises, of course, feel free to email me at bsimbeck@ccac.edu. Thank you.